In this video, we are going to continue learning about solving systems of equations by graphing. Let's begin. If the solution of a system of equations on a graph is the point of, well, what kind of point? The point in where they intersect or touch each other, so the point of intersection. That was kind of an ugly O and N. Then brainstorm and answer the following. Would it be possible to have a system of equations with no solution? Why or why not? Yes, it would be, because the lines may not intersect. Intersect. Now, would it be possible to have a system of equations with infinitely many solutions? Why or why not? Yes, if the lines are the same. Are the same. And if the lines are the same, it's like they're on top of each other, which means, if a solution to one graph is the line and the solution to another graph is the same line, then that means they share the same solutions, all of them. Infinite many solutions. So, types of solutions, this is one solution. One solution, and we have this is called no solution. If you notice, the lines do not ever touch. And this is infinitely many solutions. So, what do we notice about one solution? Well, they have different slopes, or M. What do we notice about no solution? They have the same slope, right? The slope of this line is the same as the slope of that line. That's why they never touch. But they have different what? Well, this one starts off right here. The y-intercept's up there, and this one, the y-intercept's down there. But they have a different y-intercept. So that means there's no solution. And this one is supposed to be like two lines like on top of each other, like a purple line and a red line. So it's two lines on top of each other. What do we know about this? Well, they have the same slope, right? And they have the same y-intercept. So let's solve each system of equations by graphing. All right. So I'm going to mark off my red equations with red lines and my blue equations with blue lines. Oh, it looks like for some of those equations I am going to have to do some work by rearranging them. On the first one, our slope, in slope-intercept form, our slope is 2, or 2 over 1, and our y-intercept is -3. For our blue line, I got to work this, so plus 4x to both sides. Cannot combine it with the 2, so keep them separate. This equals 2y equals 4x plus 2. And then I still need to get rid of this 2, so divide by 2, leaving me with y. Divide this by 2 and divide this by 2. Everything needs to get divided by 2, so 4 divided by 2 is 2x. 2 divided by 2 is 1, so plus 1. So my slope is 2 over 1. My y-intercept is 1. Oh, you already know something. We both have the same slope, don't we? Which means they're going to be parallel. Do we have the same y-intercept? We do not. So we actually already know the answer. Different y-intercept, same slope. What does that mean? It means these two lines are parallel. They're never going to touch. But let's go ahead and graph it out because they told us to. With our red line, y-intercept of -3, rise 2, run 1. Rise 2, run. Sorry, I messed that up. I didn't rise 2, I rose 1. Rise 2, 1, 2, run 1. Rise 2, run 1. There it is. And then our blue line. Y-intercept of 1. And they want us to rise 2, run 1. Rise 2, run 1. 2 over 1. Yep, these lines never cross. So, we know it is, what is the answer? No solution. And as many people, they go like that. That also means no solution. That 0 with a giant exaggerated slash across it. All right, let's do the next one, the red one. My slope is negative 1 over 2. My y-intercept is 4. My blue line needs to be rearranged. Need to get x on the other side, or get rid of the x on this side. So I'm left with 2y equals negative x plus 8 divided by 2. That cancels. Divide that by 2. So negative 1 over 2. That's negative 1 over 2x plus 8 over 2 is just 4. So slope is negative 1 over 2. Y-intercept is 4. Look at that. We've got slope of 1/2, y-intercept of 4. Over here we've got a slope of negative 1/2, y-intercept of positive 4. What does that mean? Is that the same slope? It is not. Let's see what that looks like. Looks like the same slope, but it's, oh wait, you know what? I messed up. This is negative 1/2, slope of negative 1/2. So same slope, same y-intercept. What does that mean? Well, let's graph the first line. We start at 4 and negative 1 over 2, negative 1 over 2, negative 1 over 2, rise, run. So that's what this looks like. Whereas when I graph the blue line, start at 4 and it looks like we intersect there, negative 1 over 2, and we intersect there, negative 1 over 2 over 2. Notice, and if I go backwards, I am intersecting everywhere. And the lines themselves, so even those decimals and fraction areas, so this is all real numbers. All real numbers. So all the solutions are true. And that should have been obvious because take a look at this equation, y equals negative 1/2 x plus 4. It's the same exact equation as right here, y equals negative 1/2 x plus 4. Let's go ahead and try go to the next page, try number 3. Complete the table by identifying the graph line that would have no solution, which with each given equation in the table, record the letter of the line in the table. So, which of these will have no solution? Now, we need to be reminded, how do we know if we have no solution? No solution means that same slope, different y-intercept. So we want to find which equation has the same slope but different y-intercept of line A and B and C. Well, we need to start by finding the equation of each of these lines. So let's go ahead and find the equation of this line. Line A, I'll do this in red. Let's choose my color. Line A is going to be red. Line B is going to be blue, and line C is going to be green, I suppose. There we go. So line A, starting point of 5. So B is 5. Let's see, where is that? Up, there we go. Rise, negative 1, run 3. So my slope is, give me negative 1 over 3. So line A is y equals negative 1 over 3x plus 5. Let's look at line B. Starting point is right here, not over here, not that, because it's not a y-intercept. Y-intercept is where it touches the y-axis, which is this axis right here. So our b is going to be -3. Our slope is what? Let's look at another point on that. There it is. 1, 2, -2 over 1, 2, 3. -2 over 3. So let's write that equation. Y equals -2 over 3x minus 3. And then let's do line C. What is our starting point? Our y-intercept, that's 1. M equals 1. What's our, sorry, not M equals 1, B equals 1. Getting my letters confused. My M, or slope, is what? Rise 2, run 1. Oh, that's just a slope of 2, or 2 over 1. So our equation is y equals 2x plus 1. All right. Now, which one will not have the same solution? We're looking for something with the same slope but different y-intercept. So, oh darn it, I actually have to rearrange these. So I have to rearrange the first one anyways. 2x plus 3y equals -12. Well, they don't give us any room, which kind of drives me nuts. But let's do it right here. 2x plus 3y equals -12. Let's subtract 2x from both sides. 3y equals -2x minus 12. Divide by 3. So that cancels. We're left with y equals -2 over 3x minus 12 over 3 is 4. I'm going to rearrange all of them. My second one is fine. My third one is fine. My fourth one needs to be fixed. So let's fix that one. I'm going to add 8x to both sides. That cancels 8x. So I end up with, it's right on the side, 4y equals 8x minus 8. Divide by 4. Gives me y equals 8 over 4 is 2x. -8 over 4 is minus 2. So y equals 2x minus 2. This equation's fine, and no, it's not. Darn it. Got to fix that one. Subtracting, got to get the y by itself. So subtract x from both sides. You end up with 3y equals -x plus 6. Divide by 3. That cancels. Divide by 3. Divide by 3. Remember, there is an invisible 1 there, so you end up with y equals -1 over 3x plus 6 over 3, which is just 2. So y equals -1 over 3x plus 2. Gonna try to highlight those. There we go. And this is fine, and that is also fine, and this is also fine. All right. See, it has a no solution with what? What does it share a slope with but have a different y-intercept from? -2/3. It shares a slope with the blue line, which is b, but different y-intercept. Let's do -1 over 3x. Which one also has a -1 over 3x? Oh, and it has a different y-intercept. So it's going to have no solution with A. -2 over 3x. Which one? Oh, that's line B. Different y-intercept. Y equals 2x. My slope is 2. Oh, this also has a slope of 2, but it has a different y-intercept. So that's going to be line C. -1 over 3x plus 2. Oh, that is going to be line A. And y equals 2x minus 1. Oh, that is line C. Same slope, different y-intercept. Let's do number 4. Ava thinks that line A and line B above would have no solution because the lines do not intersect on the graph. Is she correct? Explain your reasoning. Will line A and B have no solution because they don't touch? She is wrong. Is she correct? No. Because B/C, because the lines will eventually intersect. Now, they won't intersect in this picture, but if we keep going with this line, this blue line, it just kind of keeps going like that, and this red line keeps going like that. Up, you see? You see? They eventually touch, and they had touched like right here. I don't know what that point is, but it's a point. So she is incorrect. Line A and B do have a solution. We just don't see it on the graph. How do we figure it out? Well, we can do that algebraically. We'll learn about that later. All right. Write an equation that would have infinitely many solutions with the equation below. I know. How about 5x plus 3y equals 12? That would also have infinitely many solutions. It's the same solution. You could have also said, how about 3y plus 5x equals 12? Sure, why not? You could have rearranged it as well. You could have moved the 5x to the other side. You could have also said 3y equals, well, when we move the 5x to the other side, we subtract 5x from both sides, so we have negative 5x plus 12. That would work. Or you could divide them, and you could then divide it by 3. Y equals negative 5 over 3, x plus 4. So all of these will work. All of these are equations that will have infinitely many solutions to this one because they are the same equation. They're just rearranged differently. Number 6, Colin starts with $8.50 in his bank account and saves $15.75 a week. James starts with $7.50 in his bank account and saves $15.75 each week. Will the two boys ever have the same amount in their savings account? Explain our reasoning. So let's do Colin in red. Starts with $8.50 in his bank account and saves $15.75 each week. And James starts with $7.50 and saves $15.75 each week. Will the boys ever have the same? That is the solution in which they both intersect. Well, $8.50 is the starting point, right? Starts with $8.50. That's our y-intercept. That's our B. And then saves $15.75 each week. That is our slope because $15.75 each week, it's a rate. So M, so it's $15.75 times the number of weeks. So let's write our equation. It's y equals something. Our slope, 15.75, rate of change times x plus my starting point. And that is going to equal y, which is the total money they have in the bank account. Let's do James now. He starts with $7.50. And then he saves $15.75 a week. So $15.75 a week plus he starts with $7.50. Will they ever have the same amount in their accounts? Well, they have the same savings rate, right? He's saving at $15.75. He's saving at $15.75 a week. But he starts off with more and he starts off with less. Will they ever have the same amount in their account? No, because they save at the same rate. The same rate with a different starting point. A different diff starting point. And there you go. So now we've learned more about solving systems of equations by graphing. Whenever the two lines never touch, they have the same slope, but different starting point or y-intercept. That means you'll have no solution. But if the two lines are the same, you have infinitely many solutions, and one solution means they only have cross at one point. So go ahead and try some problems on your own. Good luck.